So in this video we're going to take a look at the different problem types that appear on your Unit 5 test review. First type of problem we'll take a look at is question 2, and in question 2 we're asked to identify each polynomial as a monomial, binomial, or trinomial, and then give the degree of the polynomial. So question 2, first thing I got to figure out is how many terms are in this polynomial to determine whether it's a monomial, binomial, or trinomial. And remember, what separates the terms are addition and subtraction. So basically we have 2 points of separation here. We have a subtraction sign, an addition sign. So it looks like I have 3 terms then in this polynomial. First term, second term, and third term. So with 3 terms I would say that this is a trinomial. Okay. Next thing I have to do is give the degree of the polynomial. Well, the degree of the polynomial refers to the number of variables in the highest powered term. So if we take a look here at each of these terms, we want to figure out how many variables entirely they have in the term. So notice the first one here, negative 5x to the 7th times y to the 2nd. I have 2 different variables there, and I have those variables to exponents. So it looks like that term has a degree 9. I have 7 of the x's getting multiplied, 2 of the y's, so altogether that has a degree of 9. My next term, I have x squared and then y to the 4th, so that would be a degree of 6. And then my last term, x to the 6th, y to the 3rd, that is a degree of 9. So the degree of the polynomial is just the highest powered term that appears in the polynomial. So in this case, both of these highest powered terms are degree 9, so we would say this polynomial is of degree 9. Okay, next problem we'll take a look at is question 9. In question 9 we're asked to subtract this first polynomial from the second. And so what I like to do when I'm faced with a word problem and I need to translate it and I have some complicated terms or polynomials or something like that in here is, let's simplify this problem. What if I asked you to subtract 5 from 7? That's a much simpler problem, and the way that we do this much simpler problem is the way that we're going to do this more complicated problem. So if I was to ask to subtract 5 from 7, what that means is I'm going to start with 7 and I'm going to subtract 5 from it to get an answer of 2. And so since that's how I've performed or translated this words to math with the simpler problem, that's how I'm going to make this translation with the polynomial. So I want to start with this last polynomial, which is negative 2x cubed plus 4x minus 7, and I want to subtract from that, oops, erase that a little bit there. I want to subtract from that this starting polynomial, which was negative 6x cubed minus 2x squared plus 3x minus 4. Okay, so I'm subtracting a whole quantity here, a lot of things inside of this polynomial. So what I want to do is I want to distribute this negative to kind of get the parentheses out of my problem. So I'm going to take this negative or subtraction sign and distribute it to every single term inside these parentheses, and I'll rewrite the problem. The parentheses in this first polynomial aren't needed anymore, so I'd have negative 2x cubed plus 4x minus 7. And now if I subtract a negative, that's a double negative situation, so I'd actually be adding a positive 6x squared. And now if I distribute the negative to the next term, that negative 2x will become a positive 2x squared. And now if I distribute it to the third term, that becomes a negative 3x. When I distribute it to the last term, that becomes an actual positive 4. So notice when I distribute that negative, it basically makes each of these terms their opposite. Now that I've got the negative all distributed, now I can just look to combine the like terms. And I would start with the highest power terms that appear in my polynomial, and it looks like my cubed terms. So I have this negative 2x cubed and this positive 6x cubed. So when I combine those, I will add those together, and that would give me a positive 4x cubed. Okay, now let's go to the next highest power term, which is my x squared terms, and it looks like I only have one of those. So I would just write that one next, so it would be positive 2x squared. Now let's go to my x terms. It looks like I have 2 of those. So a positive 4x and a negative 3x would give me a positive 1x. So I can write that as just plus x. And now finally we'll end up with our constant terms here, and I have a negative 7 and a positive 4 that need to be combined. So a negative 7 and a positive 4 would give me a negative 3. And so that is my final simplified answer when I subtract this first polynomial from the second. Now we'll take a look at question 12. In question 12, I'm asked to subtract again, except this time in a vertical format. And so the same way I did the subtraction last time, I want to distribute this subtraction or negative sign to each of the terms. And in a vertical format, I'm going to kind of just do that mentally. I think it's easier just to do that mentally as opposed to writing it all out. So I would start, and you notice that my like terms are all lined up here. That's the advantage of the vertical format. So with this 18x to the fourth, I really don't have any terms to combine with that, so that is going to remain 18x to the fourth. Now we'll take a look at my cubed terms. So I'm going to start here with negative 3x cubed, and I'm going to subtract from that 2x cubed. Well, if I started with a negative 3 and I subtracted 2, that's going to give me negative 5. So that would give me negative 5x cubed. Now we'll take a look at the squared terms. So I have a positive 5x squared, and notice here I'm going to distribute this negative or subtract a negative 2x squared. Well, that's a double negative. Minus a negative is the same thing as plus a positive. So I'm going to think of this as 5x squared plus 2x squared. So 5x squared plus 2x squared is going to give me a positive 7x squared. Okay? Same thing again. I take this negative now, or minus sign, and distribute it to this next one. And I have a minus a negative 9, so that's actually going to turn into plus positive 9. So when I go to combine these, I'll have a negative 9x, and that's going to become plus 9x. So negative 9x plus 9x is going to give me 0. So I'm not going to have any term there at all. So now I would just continue on to this last one. And here I have negative 1 minus 4. So negative 1 minus 4 is going to give me a negative 5. And that's my final simplified answer when I combine these two polynomials using subtraction. All right, next problems we're going to take a look at are practicing our exponent rules. And so in problems 15 through 30, I've just picked out some here to kind of give you the different problem types. So I'm just going to quickly go through these different problems, these 6 different problems I have here. Okay, first problem we're asked to evaluate an exponent on this this term here, negative 4y cubed. And so I just want to basically go through, since everything is getting multiplied here, I just want to go through and square each of these terms. So the first thing I do is I'd square the negative 4. Well, negative 4 times negative 4 is positive 16. Now I'm going to square the y cubed. Well, this is a power to a power situation, so I'm going to multiply those exponents then. So that's going to give me y to the 6th. Question 20. I'm asked to simplify 36x to the 0 power. Notice only the x is getting taken to that 0 power. And anything to the 0 power is just 1. So really what I have here is 36 times 1. Well, 36 times 1 is just 36. Question 21. I actually have two operations going on here. I have multiplication here, and here I have an exponent. Well, order of operations tells me I need to evaluate that exponent first. So I'm going to bring down this 2x to the 4th. And over here I'm going to figure out the answer once I take this thing to the 3rd power. So 3 to the 3rd power is 27. And then x to the 2nd power, again, raised to the 3rd power, that's power to a power. So I'm going to multiply those exponents. So that's going to give me x to the 6th. Okay, now I'm going to go through and I'm going to multiply my coefficients. 2 times 27 is 54. And then x to the 4th times x to the 6th is x to the 10th. This is the product rule. If I take a base x to the 4th, that means 4 x's are getting multiplied, and then 6 more x's are getting multiplied. So altogether I have 10 of those x's that are getting multiplied. Okay, question 24, again I have two operations, multiplication and an exponent. I'm going to start with the exponent. So let's see what I get. First thing I'll do is I'll take 2 to the 4th power, and if I take 2 to the 4th power, I'm going to get 16. Now x cubed raised to the 4th power, I'm multiplying those exponents, so that's x to the 12th. Now I'm going to go and multiply, so I would multiply the coefficients. 4 times 16 is 64. And now x squared times x to the 12th, that's product rule, so I'm going to add those exponents, would give me x to the 14th. Okay, question 26. I'm asked just to simplify this fraction here. So all I want to do is look for common factors. So I would start with my coefficients. 3 and 4, there aren't any common factors in 3 and 4. So those are going to remain the same. Now let's take a look at my x factors there. So I have 5 x's in the numerator, 4 in the denominator. Those are going to divide out. So 4 of them will divide out, and that will leave me with 1x in the numerator. Now I'll look at my y's. Notice I have 2 in the numerator, 5 in the denominator, so I will be able to divide 2 common factors of y out of both, and when I divide those 2 out, there won't be any left in the numerator, and there will be 3 left in the denominator. Okay, question 27. I'm asked to deal with some negative exponents here. So what we typically do, and there's different ways to do this, but what I like to do is I like to deal with the negative exponents first and reorganize things to get rid of the negative exponents. So I have 2 negative exponents. Here's one on that x, that's a negative to the second power, and then here's one on that y. So what that tells me to do is if this x started out in the numerator and I have it as a negative exponent, I need to move this term down to the denominator. And this y had a negative exponent on it, so what that means, I need to move this factor up into the numerator. So let's take a look and rewrite this problem. So I know I'm going to have something squared. Let's see, the 2 is going to remain where it was. The x squared has the x to the negative second has now gone to the denominator, so I have y to the third. And I'm moving this y to the negative fifth now up to the numerator. So there's y to the fifth. Now in the denominator I have the 3, x to the fourth. That negative 2 is moving down there, so that's x to the second. Now I just need to simplify this. Let's see, we'll come over here. So in the numerator now I have 2y to the 8th. Denominator, 3x to the 6th. All of this raised to the second power. So now I'm just going to go ahead and take everything to the second power. In the numerator, 2 to the second power is 4. Y to the 8th is now going to become y to the 16th. In the denominator, 3 to the second power is 9. X to the 6th is going to become x to the 12th. Okay, in the next problems, we're asked to find the product, which means we're going to multiply some things together. So we'll take a look first at question 34. Question 34, this is telling me mathematically I need to multiply everything in this set of parentheses times everything in this second set of parentheses. And so to do that, we just do it in organized fashion. First thing I'll do is I'll distribute this 3x to make sure everything gets multiplied by the 3x. And so taking a look at that, 3x times 2x is going to give me 6x squared. And now 3x times negative 4 is going to give me negative 12x. Halfway done. Now I need to distribute the 5. So I'll distribute the 5 to both of those terms. 5 times a positive 2 would give me a positive 10x. And then 5 times negative 4 would give me a negative 20. Now I'm just going to look to combine my like terms, and those are conveniently located right next to each other in the middle. So 6x squared, a negative 12x plus 10x is going to give me negative 2x, and then minus 20. So there's my simplified expression when I get done multiplying those two binomials. Okay, question 36. I'm asked to take 2x minus 3 to the second power. Well, that indicates we have 2x minus 3 times 2x minus 3. That's what something squared means. Now, you're going to have to resist temptation to actually square each of these terms. If you just take this 2 and square each of these terms like we do when it's all multiplication, you're not going to get the correct answer. If we have an addition or subtraction sign in here where we have more than one term, we have to write this out long way to do this multiplication. Okay? Once we write it out long ways, it's the same as the problem I just did in question 34. So I'll distribute the 2x, which gives me 4x squared. And then 2x times negative 3 will give me negative 6x. Now I'll distribute the negative 3. Negative 3 times positive 2x will give me negative 6x. And then negative 3 times negative 3 will give me positive 9. Last step is to combine our like terms in the center there. Okay, 4x squared minus 12x plus 9 is my final simplified answer for 2x minus 3 raised to the second power. Okay, question 40, we're asked to distribute. Notice I'm taking this. It says take this and multiply it by every single term inside of these parentheses. So we'll just go through and do that. So here I would first start looking at the coefficients. The coefficient on this first term is just 1, so I'd be thinking 1 times 2, well that's just 2. And then x squared times x to the third, product rule, so that means I'm going to add those exponents. So I get x to the fifth. Now I'm going to take 1y times y squared, so altogether that would be 3y's getting multiplied. Now I'll distribute it to the next term. So negative 3, coefficient isn't going to change. X squared times x squared, Altogether, that would mean I'm multiplying 4 x's together. And then y times y means I'm multiplying 2 y's together. Distributing to the last term, I'm again going to get positive 4. Coefficient won't change. I don't have anything to multiply that x squared terms by, so that's just going to remain x squared. And then y times y squared will give me y to the third. And now I would look to see if I could combine like terms, but chances are very slim if I'm going to have like terms here, and I don't. Okay? Question 43. Here we're asked to multiply 3 things together. Notice, just to kind of again look at a simpler problem here, if I was to multiply these 3 numbers together, the way that I would do that, I would take 3 times 2 is 6, and then I would take 6 times 1 to again get a final answer of 6. So once I know that I have to multiply this way with numbers, I have to multiply exactly the same way if I have polynomials. So I'm going to multiply this 3 times the first term and get this answer. We'll take that answer then times this next binomial. So let's see, 3 times x is 3x. 3 times 3y is going to give me 9y. So what I have now is this answer here. I want to take this answer here times the next factor, which happens again to be a binomial. So now I will distribute twice. First the 3x. 3x times x is 3x squared. 3x times positive 2y is positive 6xy. Now we'll distribute the 9y. 9y times x is going to give me positive 9xy. And then 9y times 2y will give me positive 18y. Looks like I have some like terms to combine there in the middle. So I'll have 3x squared plus 15xy plus 18y. Okay, the last problem types we'll take a look at here is division with polynomials. Question 47, notice we're dividing by a monomial. We only have one term here in the bottom. And dividing by a monomial is pretty simple. All we have to do basically is take this numerator and divide each of those pieces of the numerator by this denominator, 4x. So I'll show you what that looks like. So we're going to take 36x to the 5th, and we're going to divide that by this denominator, 4x. Notice this had a negative sign, so I'll say minus then 12x cubed over 4x, and then again positive sign here, so then it would be plus 28x divided by 4x. So all I've done is taken each of the terms in the numerator, and I'm going to divide each of those terms individually by 4x. Let's take a look at the first term. Dividing the coefficients, 36 divided by 4 will give us 9. And then x to the 5th, if I divide one of those x's out, that will give me x to the 4th. Okay, and I'm going to have a minus sign. And now I'll simplify the next term here. 12 divided by 4 is 3. And then x cubed divided by x would leave me with 2 x's left. Finally, the last one, 28 divided by 4 is 7, and x divided by x is just 1, so that last term is just going to be 7. So when I do this division, I get my final answer of 9x to the 4th minus 3x squared plus 7. Let's take a look at question 49. Notice here, I don't have a monomial in the denominator, and that makes this division a little bit more complicated. I have a binomial here, so what I want to do is I actually want to set this up as long division. A long division problem, and I'm going to put that numerator into my long division box. Okay, now I'm going to start dividing, and when you're doing this dividing, you're really focusing on the first part of this and seeing how many times it's going to go into the next thing we have over here in our long division. So I would start by saying, how many times does 2x go into 2x to the third? Well, another way of thinking about that is, what would I need to multiply times 2x to give me 2x to the third? The answer is an x squared. So what I'm going to do now is I'm going to take this x squared and multiply by both of these terms and then write them under here so I can subtract. So x squared times 2x would give me 2x to the third, and then x squared times positive 1 would give me positive x squared. And so now I'm going to be subtracting that. So let's take a look. 2x to the third minus 2x to the third is 0. That's great. I wanted that first term to drop out. And now if I have a negative x squared minus x squared, that's going to give me negative 2x squared. Okay? What I'm going to do now is, just like regular division, I'm going to bring this next term down, this plus 3x. And now I'm going to say, how many times does this 2x plus 1 go into this next part here. So I'm only going to focus on the first part. So 2x is now just going into negative 2x squared. Starting with 2x, I want to get to negative 2x squared. So all I really need to do there is have a negative x. Or you could think of this as negative 1x. Because if I take a negative x times 2x, that's going to give me negative 2x squared. Now I'm going to take a negative x times 1. Negative x times 1 is just going to give me negative x. And now I'm going to be subtracting this. So let's see, negative 2x squared minus 2x squared is going to give me 0. And now I have 3x, but notice I have a double negative here, minus a negative x. So that's the same as kind of adding x. So I'm thinking 3x plus x will give me 4x. Drop down the last term. One more step here. 2x plus 1 is going into this 4x plus 2. So 2x, to get me to 4x, all I would need is a 2. So I'm going to be multiplying by plus 2 here. 2 times 2x gives me 4x. And then 2 times 1 gives me 2. And now I'm going to be subtracting that. And I'll get 0 when I do that subtraction. Had I ended up with a remainder here, I would have written that remainder over my original divisor, which is 2x plus 1. But since I don't have a remainder here, my final answer is going to be this x squared minus x plus 2.